welcome to iFlip for Math Mathcast, lesson 11-5, area of rectangles using fractions. I'm Mrs. Gooding, and our quote tonight is by a famous American poet named Robert Frost. Those are some pictures of him when he was younger. This is a line from one of his poems. It says, "I shall be telling this with a sigh, somewhere ages and ages hence. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference." And that's kind of what we're doing today. This is a new type of lesson for fifth graders. We are going to be finding area, but we're going to actually be finding the area of rectangles with fractional side lengths. And we've never done that before. So sometimes it's a little scary and risky to try something we've never done before. But as Robert Frost said, sometimes trying something new can make all the difference. Our learning goal is to use the standard algorithm and models to find the area of rectangles with fractional side lengths. So our individual lesson learning goals are to use the formula A equals L times W. And I always use a little cursive L so you can tell that's not a 1 times W. That is a capital A for area equals length times width. And you can see on that rectangular shape right there, that figure, that is length is the long side and width is the shorter side. We're going to multiply fractional length and fractional widths to find the area of a rectangle. We are going to then convert the answers, or the product that we get there, to if they're improper fractions, to mixed numbers or whole numbers. And you guys always ask me in class, do we need to simplify this? If it's a fractional answer, you need to simplify it or it's not correct. Even I forget to simplify sometimes. I know that happens, and you also know that I have to do a push-up for you anytime you catch me and write it in your journal. I also want you to draw a model to support your answer. I think this will help you understand what you're doing as you multiply fractional side lengths. That is Robert Frost's house and his baby picture, which is kind of fun to see. Here is our vocabulary. We're going to be finding area. That's something you did in 4th grade. It's the amount of surface a figure covers. So when we talk about perimeter in 4th grade, your teachers use the description a lot of times of a fence, measuring the length of a fence that goes all the way around a garden or a yard. The area doesn't measure the length around. It's not measuring a line. It's actually measuring, if you take a whole space, the entire floor space of a room, and you're going to cover it with carpet, it's how many square units you need to buy to cover that entire floor. As we are looking at fractions again, remember that fractions represent an amount less than 1 and greater than 0. So here is our example, and there are some pictures of Robert Frost playing baseball. He loved baseball and enjoying the outdoors. He wrote about the outdoors a lot. My favorite poem that he wrote is actually October. Here's our first hint. When you multiply two fractions that are both less than 1, and all fractions are less than 1, the product or the answer is going to be smaller than either fraction. So we used to talk about comparing two fractions by cross multiplying. If you compare that product or answer to either of the two fractions that you're multiplying together, your product or your answer will be less than either of those two fractions. And we'll do a model so you can see why that is. Here's our first problem. A park is 3/4 of a mile in length and 2/3 of a mile in width. What is the area of the park? And we're going to use that formula, area equals length times width, and we're going to substitute those amounts that they gave us for the length and the width in the formula. Let's go ahead and look and see how we did that. So I rewrote the formula because I always write the formula every time I work a problem. And I substituted the measurements for the letters that they stand for. So my length is 3/4 times the width, which is 2/3. And I can use the standard algorithm to do this. I multiply it like I would any fraction, just like we did in 11-4. So I multiply my two numerators, so 3 times 2 equals 6. And I multiply my two denominators. 4 times 3 is 12. Now, I know I have to simplify because both 6 and 12 are even numbers and they're divisible by 2. So I do happen to know that 6 is half of 12, so 6/12 equals 1/2. But if I weren't sure about that, I could always make a cake. So I'm sure later in this lesson we'll be modeling that for you. Now I want to show you a model that represents that amount. So here's our rectangular shape because our length is longer than our width. And we're going to decide how many parts to divide our shape into, or our side right here into, because we look at our denominator. Our denominator is 4. That tells us how many parts there are in all along the side. So I'm going to divide this side into, oh, that's bad, into 4 what should be equal parts, but unfortunately, because I'm not an artist, they're not. And this side has a denominator of 3, so I'm going to divide this side length into 3 parts. I hope I can do a better job of making this kind of square. Now, these are squares, not lines. So when we do our answer, we have to answer in square miles instead of just miles, because we're not measuring the length of a line, we're measuring this square unit right here. So we know that we're going to color in 3 of those 4. So I'm going to color in 3 bars this way. That's 3 of 4 bars. Now we're going to change color so that you can really see the difference. And we're going to color in 2 of the bars this way, going cross, so that you can see which ones actually intersect. Do you see that I colored in 2 of the 3 horizontal bars? So that's 2/3. Now, to get my answer, I look at the squares that have kind of the crisscross. It has the green pattern one way and the pink pattern the other way, because those are the overlapping areas. So I count 1, 2, 3, 4, 5, 6 is my numerator. And then I just figure out how many squares I have in all. I do know that I can multiply 4 times 3 and get 12, but if I'm not great at multiplication, I can also count my squares, and there are 12 in all. And of course, because I have 6/12, I would need to simplify, which would give me 1/2, and I'm going to put an M for miles. Actually, I'll put an MI period. And then I'm going to put a little 2 up here. And that 2 actually stands for the length and the width. When you talk about 3D, 3-dimensional, that means you're measuring the dimensions of length and width and height. But when I'm doing area, I'm only using the dimensions of length and width. But that's 2 dimensions, so I have to put a little 2 up there. We say square when we read that, so that would read 1/2 square miles. But it actually means that we're measuring a square because we're using 2 dimensions, length and width. So you knew I would have a picture of Robert Frost with his library because I love books so much. But now we're going to do some practice problems. So in all of these problems, we're going to use the standard algorithm to find the area and then draw a model to support your answer. Some of you may find it easier to draw the model first and then use the standard algorithm to check. That's okay with me too. Here's our first problem. A rug is 4/6 of a yard in length and 1/3 of a yard in width. What is the area of the rug? Go ahead and pause it and push play when you've used the standard algorithm and drawn a model to support your answer. Did you write 2/9 of a square yard? Let's see how we did that. So I've written my formula, area equals length times width. Don't forget to do that every time. And I've substituted my fractional side lengths. So it says area equals 4/6 times 1/3. And we're going to use the standard algorithm first to solve it. So we multiply our numerators. So we have 4 times 1 is 4. And 6 times 3, our denominators, are 18. And I know that can be simplified because I have 2 even numbers. So I'm going to make a cake and put the fraction in the bottom layer of my wedding cake. Remember, simplify, make a cake, look for the bride and groom. So we think what number will divide evenly into both 4 and 18? And 2 will. So 2 goes into 4 2 times, and 2 goes into 18 9 times. And what will divide evenly into 2 and 9? Just 1. 1 goes into 2 2 times. 1 goes into 9 9 times. Once you've repeated that fraction right there, that is your bride and groom on top of the cake, or the simplified fraction. So our simplified fraction is 2/9. I'm going to put a box around that so you can really see it. Now, because we're doing square yards, when I write my final answer, I would have to write 2/9 of a square yard. And we put our 2 after the unit of measurement because if we put the 2 here, then we're squaring this fraction, and that's not what we're squaring. We're talking about squares on our rug in this case, which I'll show you right now. Remember, we're going to take our length of 4, 6, and we're going to divide it into 6 vertical bars, or 6 columns. So there's 3. There's 3 more. 1, 2, 3, 4, 5, 6. And then we are going to color in 4 of those 6. So there's 1, there's 2, there's 3, there's 4 of 6. Now we're going to change colors, and we're going to divide our width into 3 parts because our denominator is out of 3. So we make 3 horizontal bars, and we are going to color in 1 of those horizontal bars so that we have 1 of 3 colored in. So I color in this one. And now remember, we're looking at the squares that have both length colored in and width colored in. So it's got the pink and the green. And there are 1, 2, 3, 4 of those. That's our numerator. And how many squares are there in all? There are 18 squares in all. I could get that by counting or by multiplying my 2 denominators. 6 times 3 is 18. Again, I would have to simplify, but I already did that work up there. And then I have to make sure I put my unit of measurement, and I have to put that square there. Remember, that 2 means that it's 2-dimensional. It's actually a square, length times width. Number 2, a piece of paper is 3/5 of a foot in length and 2/5 of a foot in width. What is the area of the paper? Pause it and push play when you've solved it. Did you write 6/25 square feet? Let's see how we did that. So I've written our formula and substituted our fractions for it, and if we solve this using the standard algorithm, we're going to multiply our numerators together. 3 times 2 is 6, and multiply our denominators together. 5 times 5 is 25, and we know we can't simplify that because there is no number that will divide evenly into both 6 and 25. So that is our final answer, but we have to make sure we put the unit of measurement, which was feet, and we have to make sure that we put that little 2 there so they know we're not measuring a straight line, we're actually measuring a square foot. So we're going to divide our length into 5 and our width into 5, which means we're actually looking at a square right there. So to do that, that's a little tricky for me, but I'm going to do my best. Whoops. 1, 2, 3, 4, 5, and 3 of those are filled in. So let's go with a nice light yellow, I think, to fill those 3 of those 5 spaces in, those 5 columns. 3 of 5. Now we're looking at 2/5 this way. So I'm going to have to divide into 5 parts. And you kind of watch the strategies I use. My squares aren't the same size, and they should be. If they were on a grid, they would be. And now I'm going to color in 2 of the 5 rows this way. So now when I count all of my figures, I have 1, 2, 3, 4, 5, 6 squares that are filled in by both length and width markings. And that is out of 25. I know I have 25 squares in all because I could count them, but also because I can multiply 5 this way times 5 this way, which gives me 25. And I'm not done until I put my square feet, because I wasn't measuring a line right here. I was measuring this entire square, how many squares I had. So there is Robert Frost getting to meet President Kennedy and the First Lady a long time ago in the 1960s. That's really cool, a cool opportunity for anyone, both the president and his wife to meet the great poet and the great poet to meet the president and his wife. So here is some more practice. We're going to solve this using the standard algorithm to find the area of the rectangle and then draw a model to support our answer. So go ahead and do that, pause it, and push play when you are ready. Did you write area equals 8/15 square inches? Let's see how we did that. So I've written our formula, area equals length times width, and I've substituted our amount. So I have area equals 4/5 of an inch times 2/3 of an inch. And I can use the standard algorithm to solve that. So I'll multiply my numerators. 4 times 2 is 8. And I'll multiply my denominators. 4 times 3 is 15. And I look at those and I know that 2 won't divide evenly into them, and 3 won't divide evenly into both of them, 4 won't divide evenly into both of them, 8 won't. So I'm pretty sure I'm in simplest form, but I do need to make sure that I write inches square. So I have 8/15 square inches, and I'm gonna do my little diagram down here, or my model. So I look at my length and I know I have to divide it into 5 parts. So I divide that side into 5 parts, and I'm going to color in 4 of them. 4. Excuse me, I don't know why I said 4 there. There's 3, there's 4. Can't count. Have to do push-ups for that? Surely not, I caught it. Now I'm going to divide this side into 3 parts, or 3 vertical rows. And I'm going to color in 2 of them, going the opposite direction. 1, 2. So I colored in 2 of the 3 rows. So if I count how many I've colored in for both length and width, I have 1, 2, 3, 4, 5, 6, 7, 8. So that's my numerator. And in all, I have 5 times 3, or if I count them, I have 15 in all. And those are all square inches right there. So, or actually, I divided 1 inch into 5 parts, so it's 4/5 of an inch, but we're talking about square inches that we've divided up. So there you go, 8/15 square inches. So there's a great picture of Robert Frost outside getting ready to chop some wood and challenge himself and having a great birthday party with his cake. We've been challenging ourselves all night, but now it's time to really challenge yourself. But you can do it. Eagle Glen Intermediate School sits on a piece of land that is 10/12 of an acre in length and 5/8 of an acre in width. What is the area of their land? Use the standard algorithm to find the area and draw a model to support your answer. Show your work in your flip journal. Come back tomorrow ready to check your answer. I'm always excited when you guys take on the challenge and then come in to check your answers. Finishing up, there's some more great pictures of Robert Frost, and you can actually see his handwriting there. It's time to review our learning goals. This was kind of a 2 thing. You had to learn the standard algorithm, which we learned a little bit before, but then you had to be able to model it as well. So do you feel like you've mastered it? Are you at a 1 where you need some more help? Are you at a 2 where you've almost got it, but you just have a few questions that you wrote down in your journal? Or are you at a 3? You've got it and you're ready to move on. Don't forget to write those questions down. Awesome area. You have completed lesson 11-5, area of rectangles using fractions. I can't wait to see you tomorrow.